Okay, so the first type of angle pairs that you need to be aware of are complementary and supplementary angles. Okay, so complementary angles are going to be two angles whose sum is 90 degrees. Okay, so that is complementary angles. So this is an example of two. They don't have to be adjacent to each other. You could have also taken these angles here. If this is a 58-degree angle as well, then this angle and this angle are also complementary. So they don't have to be connected or adjacent to each other, but they do have to add up to 90 degrees. A pair of supplementary angles are going to be two positive angles whose sum is 180 degrees. And so those are sort of the differences between those. And once again, they don't have to be adjacent to each other, but they do have to add up to 180 degrees. So there's a number of different examples of these types of questions. We're going to go through a few of them here. Okay. So starting with this first example. Okay, I want you to see if you can find what is the value of x given the relationship that exists right here. You can see it's very similar to angle addition postulate. Okay, you have two angles. You can see what their relationship is. Solve for the corresponding value. So this pair of angles, it doesn't specifically say, but these are complementary angles. And you can see that together they add up to this right angle as designated by the squared off marking. And so if you take the sum of these and set them equal to 90 degrees, that's how you can find your measure. This is combining, or really is just applying the angle addition postulate. And so if you solve, we subtract 48 from both sides, leaving 42. Isolate your variable, and we solve, getting x is 6. Once again, make sure you're reading carefully. Is it asking you to find x, or is it asking you to find that whole angle, which would have been the 42 degrees? All right, same thing. Let's go to the problem on the far right. So same idea, but now with supplementary angles. Can you find what the x would be in that example? Most of you can probably do it with just a basic mental calculation. So this is a pair of supplementary angles, which means the expression of 2x plus the 90 has to equal 180. And so when you solve this, you get 2x is equal to, subtract 90 from both sides, and then divide by 2, and you get your x value to be, 45 degrees. And once again, double check, make sure it's asking you to find x, not what the actual angle measure is. All right, so that's kind of the sort of bridging the gap between the angle addition and these complementary and supplementary angles. I want you to answer these two middle questions here. And see if you can find what is the supplement and complement of a given angle measure just using the definitions. And because the complements and supplements have to be positive angles, it is possible that DNE, there does not exist, is what that stands for, and it does need to be all capital letters. Okay, but if there is no complement or is no supplement, go ahead and write DNE as your answer. Once again, you can enter your answer as calculations, which I do encourage you to do. It generally makes it a nice, easy answer entry. So what could we enter here to get the supplement of 39 degrees? Easiest thing is to just write the calculation. 180 minus 39, and that's going to be your solution. The little previewed answer will show up over here as 141. So again, you can enter it as the calculation or the calculated value. To find the complement, 90 minus 39, same concept. Take what the total sum is, subtract the given part, and that will preview the remaining value, which would be the 51 degrees. Now, one of the ways that I think about, or I remember thinking about the difference between complementary and supplementary angles when you don't have your notes available, is I look at the spelling of them, because usually that will be part of the question, right? What's the complement or the supplement? Notice a couple things about the spelling here. Complement has one P in it. Supplement has two. What I remember doing is I remember kind of thinking that P in a mirror looks like the number 9, which corresponds to 90. So complement has one of those, 190, and supplement has two 90s. And so when you're trying to decide, is complementary 90 or 180, does it have one P, 190 degree, or does it have two Ps, two 90s? And that's, again, I recall thinking of it that way. Okay? So working through this last example here, 180 minus 146. When you calculate that, it is going to preview a positive number, 34. And so that would be your answer. That is the supplement of 146. But if you tried to do this with a complement, you're going to get a negative number. It cannot be negative. So you can't enter this as a calculation. You need to understand that if it's a negative, if it's an angle that is beyond 90 degrees, or again, even 90 itself, it has to be a positive angle for these. And so anything that's a 0 or a negative number will have DNE, does not exist, as the solution. Okay. All right. Questions on that? So those sets of questions would be what I would consider like the really basics of this. The last two questions are ones that are a little bit more challenging. Okay? And so I'm going to talk through how to do the first one, and then I'll have you try the second one on your own. Okay? But the idea here of using ratios, and this is the first time that we're talking about ratios, but ratios are going to come up in a number of different questions where you have known values for a whole. Okay, because there's two ways that you can work with ratios. You can work with them by thinking of them as part-to-part ratios. Or you can think of them as being part-to-whole. Okay, I'll talk about both, but I'll also mention, to me, using part-to-whole is the more efficient and the more advantageous way to think about it. But if you if you don't think that way, if that's not how your brain works, then the part-to-part is also fine. They're both acceptable ways to write it. All right, so here's how I would approach something like this. A pair of complementary angles has a ratio of 4 to 1. And so if you're going to solve this using part-to-part, best thing to do would be to sketch an example of it. It doesn't have to specifically be to scale, but complementary angles add up to 90, so the easiest way to sketch it is just to use a 90-degree angle. And then what you're going to use is you're going to use the ratio as the coefficients or multipliers of some unknown. What you know is that 4 times some number, x, and 1 times that same multiplier, x, together those have to add up to 90 degrees. And so what you're doing is you're creating this part-to-part. It's 4 parts to 1 part. And so the equation for that would be 4x plus 1x is equal to 90, and we solve it like we did the problems up above. We get 5x is equal to 90, divide by 5, and kind of squishing stuff together here. But when you divide by 5, 5 goes into 5 goes into 9 once with 4 remaining. 5 goes into 48 times. So your x value is 18. Well, that's your smaller angle. Notice it says separate these, you're listing the pair of angles. So 18 is one of them. You plug that back in up here. So 1 times 18 is 18. And then 4 times 18 would be the other. Again, you can either type it as a calculation or you can enter it specifically. And if you subtract 18 from 90, you get 72. And so those would be your two different ways to enter your answer using part-to-part ratios. Now, let me talk about part-to-whole ratios. Okay, so if you're using this concept of part-to-whole ratios, what you're going to look at is if we take this ratio of 4 parts to 1 part, how many total parts are there? 4 parts and 1 part. Total of 5. So what that means is that the larger angle is 4 out of those 5 parts, and the smaller angle is 1 out of those 5. And what's the total sum? The total whole is, for complementary, 90, right? So the other way to use part to part or part to whole ratios is to think that the larger angle is 4/5 of the whole, and the smaller angle is 1/5 of the whole. And so that would be, you come up with the exact same answers, right? 18 and 72. But it will often lead to like a really direct calculation where you don't have to do a ton of work, because the understanding is that the larger one is 4 out of the 5 parts, the smaller one's 1 out of the 5. All right, so try this question to the right. See if you can find the pair of supplementary angles with a ratio of 2 to 3 using either of those methods. Either part-to-part ratios, sketch a diagram and solve it, or you can use part-to-whole ratios and just base it off of the given ratio itself. Hey, how many of you used part-to-whole? Okay, and how many used part-to-part? Okay, so sketch the diagram. So that's, if you've ever been exposed to problems like this, that's probably the method that you've used, which is why it's the more familiar one. So let's look at it in that way first. So here, if I have this ratio of 2 to 3 that are supplementary, my sketch is just going to be a straight line. So if I sketch that, I have 2 times some multiplier. Oops, I'm going to kind of do them a little more to scale. So the smaller one is 2 times some multiplier. The larger one is 3 times that same multiplier. And so I know that if I combine these, I get 3x plus 2x is going to equal, supplementary means a total sum of 180. And so I get 5x is equal to 180, divide by 5. And I get my x value here. 5 goes into 18 3 times with 3 remaining. 5 goes into 36 times. So my x value is going to be 36. Now, this is not one of the answers. Notice, when you're solving this by using part to part, you need to plug this back in. So this is 2 times 36, and this is 3 times 36. And so when you write your answer, 2 times 36 is 72. 3 times 36 is 108. And so those would be your solutions. Okay. If you were solving this using part to whole, if your ratio is 2 to 3, how many total parts do you have? Again, it's 5. It won't always be, but you know that the smaller one is 2/5 of the whole, the larger one is 3/5 of the whole. And because we're dealing with supplementary, our whole is 180. And so you can enter your answer as those individual calculations, or you can do the calculation and you'll get the same thing, 72 and 108. Like I said, to me, thinking of it in terms of part to whole can be a time saver. Right, that slide's pretty full, sorry about that. But I did want to show a number of different examples of how you can use these complementary and supplementary angle pairs. All right, the next slide has to do with describing some pairs of angles. This next type is a pair of angles called adjacent angles. Adjacent angles have the following conditions. Again, it's a pair, so there's 2 of them. They have to be coplanar. And they have to share a common vertex. And they have to have a side in common but no common interior points. So basically what you're going to see when you have adjacent angles is that together the angles will be the parts of a whole. Okay, so if you start with an angle here and you create another angle off of this same vertex here. So we have angle 1 and we have angle 2. Those are an example of they create this whole angle here. That means those are adjacent angles. So if two angles are parts of the same whole without any overlap, then you have adjacent angles. And so based on that description, I want you to see which of the examples below, and it can be more than one, which of them have adjacent angles that can be labeled LKJ and JKM. So see if you can find which of the examples are adjacent angles. LKJ and JKM. Okay, so obviously, coming in and counting these angles and just looking to see, does LKJ, is that an angle on the diagram? If yes, kind of make a mental note of that, and then check to see, is JKM also an angle on that? Yes. Do they have all the conditions of the adjacent angles? Yes. Well, that's kind of a cumbersome strategy, and it takes a lot of kind of remembering things. So don't be afraid to label what you have. So in the example that I used right here, I was able to label two parts, part 1 and part 2 of a whole. Okay, and so that's what I'm going to do for this. I'm just going to go into each of these examples. I'm going to label LKJ angle 1. I'm going to label JKM angle 2 if it exists or if they exist. And then I'm going to see which of those fits that pattern where they're two parts of a whole. Okay, so when I look at the first example, LKJ is this angle right here. JKM is this angle right here. Do those fit the conditions that I was looking for? Yeah, they're two parts of the whole, so that one works. Let's look at the second example. LKJ, here's the first one. JKM, here's the second one. Are those two parts of the whole? Yep, it fits all those conditions, right? Common vertex, common side, no common interior points. Next one, LKJ. So LKJ, there's my first angle. JKM. JKM is this 0, this rotation of 0 degrees. So that's not the example. So I can disregard that. And then finally the last one, LKJ. Here's my angle 1. JKM is the same angle, right? Those are just two different ways to name the exact same thing. So once again, that is not considered an adjacent angle. Okay. But don't be afraid to add your own, what are called auxiliary lines, so like your own markings to things, okay, to help you with your strategy. For the most part, again, you will see a question like this where you're just asked to label or identify adjacent angles, but for the most part, that term is just something I'm going to use, and I assume that you understand what I mean when I say it. So I actually happen to use it before we defined it in these, right? Because when I kind of talked about this first set up here, complementary angles and supplementary angles, I mentioned that those are adjacent angles, but they don't have to be. That's what I mean. If there are two parts that form a whole, those are adjacent, but both complementary and supplementary angles do not have to be adjacent angles. All right, let's jump to the next pairings, or the next angle pairings. And these are the angle pairs that are formed when two lines intersect. Okay, so here if you look 3, 4, 5, and 6, these are both of these boxed examples have the same set of intersecting lines. Okay, when two lines intersect, every angle pair is going to be one of these two things. It's either going to be a linear pair or it's going to be a vertical angle pair. A linear pair is going to be the pair of adjacent angles. So I'll abbreviate that as ADJ for adjacent angles that are formed when two lines intersect. Okay, and vertical angles are going to be the pair of non-adjacent angles formed. Oops. So here when we're looking at the linear pair, Angle 3 and angle 4 are a pair of adjacent angles. That's a linear pair. Angle 4 and angle 6, also a linear pair. Angle 6 and angle 5, also a linear pair. Angle 5 and angle 3. All of those are the adjacent pair of angles. Those are your linear pair. Vertical angles are the ones that are non-adjacent. So when I look at angle 3, there's only one angle that's not adjacent to it in those pairings, and that's which angle? 6. And when I look at angle 4, angle 4's vertical angle is 5. Okay? And so that's just the labeling of these. We'll talk about the relationship between them in the next slide, but this is just labeling them. Okay, so what I want you to do is, based on those definitions, see if you can answer this question below. You're either going to write vertical angles, linear pair, or no other answer choice. Okay, and again, these have to be intersecting lines to form the linear pair or vertical angles. All right, what about angle 5 and 6? What kind of angle pairings are those? They're adjacent, they're formed by intersecting lines, therefore they are linear pair. Perfect. And then 6 and 8? 6 and 8 are vertical. Okay, so that's just recognizing what type of angle pairing you have. Okay, this final slide in Chapter 1 is going to discuss the relationship that each of these pairings has, because each one has a specific relationship. Okay, and that is a linear pair, because they are adjacent and they form a straight line, they're going to add up to 180 degrees. Okay, so a linear pair are supplementary. They're going to add up to 180 degrees. And vertical angles, the relationship that exists here is they are going to be congruent. And remember, congruent means they're equal in all respect, which means they have the same measures. So if we were to look at the different relationships here, angle 3 plus angle 4 equals 180. Measure of angle 4 plus measure of angle 6 equals 180. Measure of angle 6 plus measure of angle 5 equals 180. And finally, measure of angle 5 plus measure of angle 3 equals 180. This is all the definition of linear pair. Okay? A linear pair add up to 180 degrees. And so if you see this, we can defend a statement in green here by saying either definition of linear pair or specifically say the relationship that a linear pair add up to 180 degrees. Vertical angles are congruent. So that relationship is that angle 3 is equal to, we already established these, angle 6. And angle 4 is equal to its vertical angle pair, angle 5. So again, if we were justifying those statements in green, we could either say definition of vertical angles, or we could say that vertical angles are equal. All right. So let's take a look at some of the more challenging types of questions you'll see in this homework assignment. So I want you to try the problem on the left, at the bottom left. See if you can solve this based on the given expressions and the definitions that we just talked about. So once again, having a very consistent strategy is always going to be useful for this. If you recall, we talked about this is one of those problems where you're solving for x, but the question's not asking you for x. So the way I would start with this is I take the expression for SWR. So here's SWR right here. This angle is expressed by 4x plus 15. So I'm going to think about that. I'm going to write this down here on my scratch paper first. And then this is going to help remind me that solving for x is not the destination for this question. Okay? It's just like a pit stop. You're going to stop at that point. And so for me to solve for x, what do I need to do to the given expressions? What type of angles are these? They're vertical angles, so they are congruent. And so if I set 4x plus 15 equal to 12x minus 18, I can solve. And now it's just a matter of solving. Here, we see this equation with one unknown. Means we're going to get rid of any grouping symbols. There are none. We're going to combine our like terms. So I'm going to move my x's to one side, my constants to the other. And so here I get 33 is equal to, when I look to solve, combine my x's, I get 8. Divide by 8. Now, this isn't a friendly integer value. This is a fraction or decimal. But when I enter this, I'm not going to enter the decimal value. I'm just going to keep it as a fraction, right? 33 over 8. And this is going to give me my previewed value, 31.5. I can't emphasize enough, even when it tells you to round to a specific decimal place, you can't round the number you're plugging in. And you can only round your number at the very end of the calculation. Okay? So if you're using a calculator for this, now the dividing by 8 does give you an exact answer. It gives you, or not an exact answer, but it gives you a terminating decimal. Okay? And so if you are using that, make sure you enter all the decimals, even if it goes past the hundredths place. Okay? It's not until you write your final answer that you can round. Okay? Use exact values up until that final answer is calculated. That's why, again, I will always, on the examples, I will always use exact values. Enter your answer as a fraction anytime you can. All right, final question is, once again, a slightly more challenging question. I want you to see if you can solve this on your own if you haven't already. So this is a problem you have the two different ways to solve it. And now the way that the problem's set up, it really encourages you to use the part-to-part ratios here, because it says that two angles form a linear pair, and I saw most of you kind of sketched a linear pair. One angle is 9 times the other. Well, if we designate one of the angles to be some unknown value, we'll call it x. The other one is 9 times that, so we can express the other angle as what? Yeah, simply 9x. Now you have your linear pair. You can solve this as a part-to-part. You know that the total of a linear pair is 180 degrees, and so now it's just the sum of the parts is equal to the whole. 9x plus x equals 180. 10x is equal to 180. Divide by 10, and you get x is equal to 18. So our smaller angle, we've got to go back in and plug that in. X is just the smaller angle, so 18. And then the larger angle is going to be 9 times that. You can either enter your answer as the calculated value, or if you think of this, 9 times 10 is 90. 9 times 8 is 72. 90 plus 72 is 162. And so those would be your answers. Now I mentioned there's options, right? Since there's sometimes a problem like this might say that it's 5 more than 9 times. If that's the case, then you have to set it up this way. But if it's just 9 times, you see that these have a ratio of 1 to 9. And so what you could do is you could solve this as a part-to-part, or the part-to-whole ratio too. So if you have 1 part and 9 parts, how many total parts do you have? 10. So the smaller one is 1/10 of the whole. The larger one is 9/10 of the whole. You know, because it's a linear pair, that the whole is 180. And so those would be your two calculations. It's going to give you the exact same thing. 18 and 162 would be your answers.